Hi, welcome again. This is video number 8 of our course Numerical Analysis for Computer Engineers. And today we are going to solve our midterm exam questions. Alright, we have our paper here and I'm going to start with question 1. Question 1 is construct a real number using your student ID. Use the first 2 digits as integer part. Use the last 2 digits as decimal part. Alright. This was my student ID and you should use your own student ID, and the first 2 digits is 24 and the last 2 digits is 12. So my real number is 24.12, 24.12. And what does it ask? Find the closest binary representation of this real number. Calculate an error according to number of decimal digits from 1 to 5. Present these results in a table. You can find an example table with the first 2 rows. Okay, and for this question, please upload a handmade solution including the error table. So, I'm going to start with the 1. And I'm going to use just one number of decimal digits. So first, I want to calculate the binary representation of the integer part. So we have 24, and to calculate the binary representation, we can just have the powers of 2, right? So we have from right to left, we have 2 to the power of 0. And 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, and it goes like this. Alright, so this is equal to 1, this is equal to 2, this is 4, this is 8, and we have 16 here, 32, and 64. Alright, our number is 24, so we can use a 16, obviously. We cannot use 32 because it's larger than our number. It's greater than 24. So I'm going to start with 16. Alright, so we will have a 1 here. And then we can use this 8 to get our number, 24. So this must be another 1 here. And then it makes 16 plus 8, it makes 24. So we can just use zeros for the rest of the powers of 2. So our integer part is 1, 1, 0, 0, 0. Alright, this makes 24. This makes 24. And then when we want to calculate for the binary representation for the decimal part, we have 1 and 2, and this time we're going to use the negative powers of 2, so we have 2 to the power of minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, and goes on. Alright, let's calculate these numbers, and this is 1 over 2, so we have a 0.5 here. This is 1 over 4, so it makes 0.25. This is 1 over 8, and it makes 0.125. Sorry, 125. I'm gonna use a calculator to get the exact numbers for the rest. So let me run a calculator. For the 2 to the power of -4, we have 1/16. So it makes, let me use this area now, 0.0625. And for 1/32, it makes 0.03125. All right, so we just need 5 numbers because in the question it says calculate an error according to the number of decimal digits from 1 to 5. So we have 1 to 5. We have the numbers for just this part. All right, now what is it asking? Find the, let me mark this part. Find the closest binary representation. Find the closest. And for this row, I'm going to use just one number to get the closest one. All right. So if I use this one, so the difference, if I use this one, the difference should be 0.5 minus 0.12. So it's a big number. If I use this one, it makes 0. Sorry. It's a mistake. Sorry. I just have this number. And I have to decide, should I use this number? So should it be a 1 or a 0? If I use 0, then it makes 24.0, obviously. If I use a 1 for this digit, then it makes 24.5. And I'm gonna calculate the difference. If it is 24.0 minus 24.12 and 24.5 minus 24.12, which is the closest one? And obviously, this is the closest one, right? This is the closest one because we have just 0.12 for our error here, but in this part we have 0.38. Then I'm gonna pick 0. So the number here, the number here for the first row should be 1, 1, this number, 1, 1, 0, 0, 0 for the integer part. And if I'm gonna use just one number for the decimal part, so it should be 0. It should be 0. All right. So it makes 24.0. Then the error must be 0.12. This is how you can solve this problem. Then we're gonna pass to the second row, and this time I should use 2 decimal digits, and I'm gonna clean this part. Now I have this digit and this digit. So if I use 0 for this part, and then if I use 0 for this part, then I'm gonna get again 24.0, right? But if I use 0 for the first digit and then 1 for the second digit, then we have 24.25. All right? So I'm going to calculate the error again. 24.0 minus 24.21 and 24.25 minus 24.12, sorry. So this is 0.12, and this is 0.13. All right, so I'm gonna pick this one again. So it should be 11000, and for the decimal part 0.0. All right, 0. Okay, so this example is a tricky one. All right, because in this example I'm gonna use I have used this digit and then this digit. So it was a tricky one to make you calculate again if you have the number 12, which is the same number with my student ID. So this was a tricky one. All right, the second row should be, for the decimal part, 0 and 0. And when it comes to the third row, I'm going to calculate this part. All right. For the integer part, again, we have 11000, and for the decimal part, now I can use 3 digits and these 3 numbers. So if we have 000, then it makes 24.0. If we use 010, then we have again 24.25. And if we use 00 and 1, and then we're going to have 24.125. All right, obviously this is the best one if we calculate the error for all these 3 numbers. And of course you can use another calculation. Sorry, this part, I'm gonna use this part to make you see the solution. So 125 minus 2412. All right. Of course, you can use another combination. For example, 110 or some another combination. You have free to calculate. So it makes 3, 7, and 5. All right. But the best one is this one, because the error comes from here is 0.005. So I'm going to pick this one now, and it makes 113, 3 of zeros, and then for the decimal part we have 0, 0, and 1. All right. Then for the fourth row this time, and now I think you get the main idea. And now we can use these 4 digits, and obviously we are going to use 0 for the first one and 0 for the second one, because this is larger numbers according to our decimal part, 0.12. So then we are going to use 1 for this part because this is a very close number. And then if we use a 1 here, then our number becomes 24.1, not 2, 1, 8, 7, and 5. All right. But if we don't use this digit and take 0 for this digit and then 1 for the third digit and 0, 0, then our number becomes again 24.125. And obviously the error of this combination is much less according to this one. So I'm going to pick this combination again. So it's 11000.0010. All right. And for the fifth row, I'm going to apply the same drill. This time we are allowed to use all these 5 digits, and I'm going to use 0 for this digit, 0 for this digit, and 1 for this digit, 0 for this digit again, and 0 for this digit, right? All right, so this is 11000.00100. All right, this is our binary representation for our real number, constructed real number, 24.1 and 2. But how can we find the exact solution? And also, you can use the errors. Let me decrease the size for this cells, and this is 24.125 and 0.005, and these two rows are the same. So what is the exact binary representation? You should use all the digits to find the exact solution, because this, you pick this digit, and this number 0.125 is larger according to this number, right? So we have a positive error here. So we are gonna use the smaller numbers to get a sum, and then find the closest representation. All right. So maybe you should use 10 or 11 digits. I don't know. All right. Yes, I took a small break and calculated the exact representation for this number, 24.12, and this is the exact solution. You need all these digits to find the closest representation. And in this question, I limited you to use at most 5 digits. All right. So it starts with the 4th digit, as you see, and used 5th, 6th, and 7th digits, and use some another digits to make the error smallest. Okay, now this was the solution of the first question, and it's time for the second one. Okay, and it says in a Python notebook, import the libraries given below. All right, start a random number generator sequence by using your student ID. All right, and define the function given below. We have a function, generate mu and sigma before using them. All right. Now you have your custom function. Please find the derivative of this function at x equals 0 by using the second central difference approach. Fill the below table using the specified step size h values. For this question, please upload a Python notebook file with q2.ipython notebook file name. Okay. And then I should start my Jupyter notebook. I'm going to create a new Python 3 notebook and use this area. Okay. And now what does it say? It says from math import exp and import numpy as np as always, and import matplotlib dot pyplot as plt. Okay, and start a random number generator sequence. All right, I'm gonna start np.random.seed. Okay, I did it. I'm gonna define this function f, x, mu, and sigma. These are our arguments, and our function returns this mathematical expression and np dot square root of 2 times np dot pi times sigma. I'm going to check the brackets. All right. Yes. np dot exponential minus np dot power of x minus mu over sigma and second power, all right, over 2. This is our function. And I'm going to generate mu with the np.random.random. So this should be a random number, a random real number between 0 and 1. And then sigma np.random.random with the same interval between 0 and 1. All right, then I'm gonna find the derivative of this function at this point, x equals 0, by using the second central difference approach. So I'm gonna pause the video now and find my codes. I think, if I remember correctly, I wrote the codes for this approach, second central difference approach. All right, I have found my codes, which I wrote in video number, I don't remember, 5 or 6. And I'm gonna continue by plotting our function to see and first I should create x values. I'm gonna check the function and I'm gonna create some x coordinates between, for example, -5 and +5. And let's say that we have 120 points. All right, and let's plt.plots x values with our function f with these x values and mu and sigma, and let's show this plot. All right, yes, we have this function with our generated numbers, and obviously this is a normal distribution, which we can also call Gaussian distribution. And I'm going to calculate the derivative of the function. And how can we do this? As we wrote the codes in previous videos, first I'm gonna define our second central difference function like this. I think you remember. let's define this function, and we should use, but not like this. We should correct this code with what? Of course, with mu and sigma. Because remember that when we wrote this code in the previous videos, we just use a function with just one argument, and this was x. But now, in this function, we have three arguments. We have x, mu, and sigma. So we should correct our numbers now. All right? So let's add some arguments to this function, which are mu and sigma, and then correct this function call with our arguments mu and sigma. And obviously, we should do the same thing for also this one, and also for this guy here, right? And also for this guy here. Do we have another call? No. Now we have the correct function call for our f with three arguments, x, mu, and sigma. And we have the correct definition of the second central difference approach now. All right, then I'm gonna define the point that we want to find the derivative of this function, which given in the question as x equals 0. Sorry, x equals 0. All right. Okay, and I'm going to correct this one and this one again. Now, I'm going to define h numbers. In this table, I see starting from 10 to the power of -1 to 10 to the power of -5. So we're going to define our h numbers in the range of 10 to the power of -I for I in range 1 to 5. All right, then I'm gonna define my second central differences with our function second central difference for obviously f, x, mu, sigma, and h. All right, this is correct, right? For h in our definition, this definition. So it's going to calculate this function, second central difference, for any h number in this range. So it's going to start from the 10 to the -1 to 10 to the -5. All right, now we just want to see the numbers in these two variables, hs, and second see the second central differences approach numbers. So I'm going to use a format for this purpose. And let's define this format quickly. I took a break and write this definition for you. this one. Okay, we have these numbers, and as you see, we just need to make it 6. and this is a problem because we changed the values, and I'm going to start to restart my kernel and run all these cells again. Okay, start from scratch. Now we have our numbers, and let's calculate these numbers and show my numbers. Okay, now we have our table, and as you can see, we have a 1.516, if you can see, 6, 4, and 3 here for the step size 1 to the minus 10 to the power of minus 1. And then it becomes 1.51616, and it goes with the same number for the rest of the part, but it changes very slightly, as you can see. It changes very slightly. And in this question, I was asking for these numbers. And of course, if you change this seed number, and seed numbers means it's a starting condition for our random number generator, and when you use your student ID, it changes mu and sigma numbers, so you will have another set of numbers. And let me try it for you. Let's change the number similar to your student IDs, for example 290 and 315, and make it 045. I'm going to run the cells again, and now we have this function. All right, so it's personalize your question with your student ID, and then I'm going to define all these numbers and get these numbers now. So your student ID changes your question and your solution, your results. So I'm going to check your results by using this notebook, by using your student ID. So this seed procedure using a student ID or using any other specific numbers makes your results reproducible. This is a very important aspect in science. So all the results we have must be reproducible. So, and we came to the third question. And third question, I think we have the same question in the last video, maybe. Video number 7. Let me check this.
Hi, we are together with the video number 7
Let me check this.
of our matrix.
Yeah.
And with these
This one?
coefficients, we have two.
Yeah. This question is this one. How? I just changed the factors. I just changed the coefficients for you. If you multiply this equation with 1 over 2, and if you multiply this equation with 1 over 3, and if you multiply this equation with 1 over 5, you will get the same sets of these equations. And obviously, as I said in the exam, you should use z here instead of y. It's my mistake. All right, then if you multiply this equation with 1 over 2, then you get 2x plus y plus z equals to 8. And then if you multiply this equation with 1 over 3, then you get x plus y minus 2z equals to minus 2. And if you multiply this equation with 1 over 5, then you get x plus 2y plus z with this correction equals to 2. And the same solution occurs for this sets. So this was a bonus question actually. So the solution I can show you. You can watch this video again for the complete solution. So I just want to see the numbers. So our numbers x equal to 4, y equals to minus 2, and z equals to 2. All right, this was our midterm exam. I hope you get very well grades from this exam, and see you in the next video.